So in question 2.9 part A, we are asked to sketch rough graphs of both the wave function psi and the probability density psi squared for n is equal to 4 and n is equal to 5. We're dealing with particle in a box states, energy states. So let's first write down the wave function. Which is this. Psi squared is going to be 2 over L times sine squared and x over L. So we need to plot these functions. Then n is equal to 4. There are 3 nodes. So within the one-dimensional box, there are 3 points along the x-coordinate where the value of the wave function becomes 0. So we need to identify at what points along the x-coordinate does the wave function become 0, right? So the fact that the wave function becomes 0 implies the sine n pi x over L term is going to be 0. I am actually going to write it as 4 pi x because we're dealing with n equals 4 quantum state. Now, sine theta equals 0 implies the value of theta is going to be an integer multiple of pi. N can be 0, 1, 2, 3, so on. Now I'm going to simply cross out the pi. That'll give me x to be ml over 4. That implies x can be 0, which is one end of the box. When m is equal to 1, it's L over 4. M is equal to 2, it's 2L over 4. It's the same as center of the box. Then you have 3L over 4, 4L over 4, 5L over 4, and so on. Now, anything from 5L over 4 is not valid because that's outside the box. And 4L over 4 is nothing but just L. So from this, we know that psi of x equals 0, L by 4, L by 2, 3L by 4, and L is 0. Right? And we also know that because we're dealing with a sine function, it's an oscillating function, and there's going to be a peak at some point. Right? So the maximum value or the minimum value you can have for sine is going to be, it has to be either plus or minus 1. Right, that will be the maximum value, and the minimum value, plus 1 would be the maximum value, and the minimum value would be a negative 1. So this would imply 4 pi x over L is going to be some n pi over 2, where m is an odd number. Right, now I'm going to cancel out the pi. That gives me x to be equal to ml over 8. And x can be L over 8, 3L over 8, 5L over 8, 7L over 8, 9L over 8, and so on. But anything after 9L over 8 is invalid because it's outside the box. So from here, when x is equal to L over 8 and 5L over 8, the value of the wave function is going to be, it's not going to be 0, but it's going to be, 2 over L times half times sign of the function, which is just equal to 1. So it will just be 2 over L to the power half. And the wave function at x is equal to 3L over 8 and 7L over 8 is going to be negative 2 over L to the power half, because the value of sine 4 pi x over L here is going to be a negative 1. So these are some of the key points we need to keep in mind while making the plot. So let's actually try and make a plot. Let's say this is the box L, and you have 0. And I'm gonna kind of split it into 8 parts. Roughly 8 parts. It's not even, but now at 0, the wave function is going to be 0. At L, it's going to be 0. Right? We know that. And we know that this is L over 8. This is L over 4. So here it's going to be 0. And it's going to be 0 at L by 2, the center of the box. It's also going to be 0 at 3L by 4. We know that from here. And we know that, let's call this to be root 2 over L. And let's call this to be negative root 2 over L. Okay, so we know that at x equals L over 8 and 5L over 8, the wave function has an amplitude of root 2 over L. And at x equals 3L over 8 and 7L over 8 has an amplitude of negative square root over L. So I'm just gonna join these values to draw this wave function. So this is how the wave function would look like when you have when you're in a state n equals 4. So this is the wave function. Now I am gonna draw psi square of x. Right, psi square of x is just going to be the psi of x squared. So it's gonna be 0 at 0. Wherever the wave function is 0, the psi squared value is also going to be 0. And when psi of x is root 2 over L, the psi squared of x is going to be 2 over L. So the value here is going to be definitely higher, right? So I'm just gonna call, let's say this value to be 2 over L, maybe somewhere here to be, we don't really have negative values because we're dealing with psi squared, remember? So when it is root 2 over L, psi squared is gonna be 2 over L. Negative root 2 over L, it's still gonna be 2 over L. So now that I have these values, I'm simply gonna join them. It's not a great picture, but you get how it's done. It's a rough plot. So that's the story for n is equal to 4. And let's do a similar thing for n is equal to 5. So this is the wave function and the square of the wave function. Let's identify where the function is 0. All the values starting from 6/5 are invalid because they're outside the box. So psi of x equals 0 so these are the values at which the wave function is 0. Now, maximum value, which is root 2 over L, that would imply this is equal to 1. And psi of x, if it has to have a minimum value, that's going to be this. And that comes from the fact that the minimum value sine can take is a negative 1. So let's cancel out this stuff and identify what the values are. So here x can be ml over 10. Here also x can be ml over 10. Now, the maximum value of psi of x would imply x is L over 10, 5L over 10, or L over 2, 9L over 10. You can also have 13L over 10 and so on, but these are not valid because they extend outside the box. Now, minimum value of psi of x would imply x is equal to 3L over 10, 7L over 10, 11L over 10, and so on. These values are not valid again. So to summarize, psi of x equals to L over 10, L over 2, 9L over 10 would be this, and psi of x equals 3L over 10, 7L over 10 would be negative 2 over L. Okay, now that we know these values, let's actually try to make this as spacious as possible. So this is 0, this is L. Now I'm going to divide this into 10 equal parts. 10. approximately equal parts. So these are the different parts. So the wave function is 0 at 0. L over 5 is nothing but 2L over 10. 2L over 5, 3L over 5, 4L over 5, and yeah, 4L over 5, which is 8L over 5. So here, the wave function is 0. The wave function is positive, and let me call this root 2 over L, this negative root 2 over L. So at L equals 0, 5L over 10, 9L over 10, and at 3L and 7L over 10, we're going to have the negative values. Now I'm just going to join these things together. So this is how psi of x looks like. And we can see 1, 2, 3, 4. There are 4 nodes, is n minus 1, right? So that checks out. Now let's draw psi square of x. Psi square of x is just going to be the square of psi of x, which is just 2 over L. So wherever psi of x is 0, psi square of x is also going to be 0. So that's very easy, right? And everywhere else, the maximum or the minimum of psi of x are going to correspond to 2 over L while drawing psi square of x. So it's going to be 1, 2, 3. So this is what it looks like for n is equal to 5. Psi of x and psi square of x can be sketched out like this. Now let's move on to part B. Use calculus to find the slope of the psi squared curve for n is equal to 4 at x is equal to L over t. And check that your curve was drawn with the correct slope. Now we need to find the slope of psi squared. So for n is equal to 4, psi square is 2 over L times sine square 4 pi x over L. Right, so this is the value of psi square. Now the slope is nothing, the slope is nothing but the derivative. So the derivative is going to be this. So now the derivative at x is equal to L by 2. So I'm going to multiply this first. So these 8 2s are 16 pi over L square. times sine of 4 pi times L over T. I'm going to cancel L. And this is just going to be 0, right? Now, in the plot, we actually have a 0 there. This shows that we actually got it right. And yeah, this solves the problem.